Happy Monday! I am so happy that you are tuning in this week for another week of online learning. Today you should have done A and B on your daily rigor. So here is A. A says compare using less than, greater than, or equal to. So we have the numbers 2,795 and 2,800. So remember, when we're comparing numbers, we always start with the largest place. So the largest place here is the thousands place. So we have 2 and 2. I can't tell which one's greater, so I have to move on to the next place. The next place is the hundreds place. I have 7 and 8. 8 is greater than 7, therefore 7 is less than 8. So 2,795 is less than 2,800. All right, 5,018 is greater than, less than, or equal to 5,009. So we have 5 and 5, can't tell. 0 and 0, can't tell. 1 and 0. 1 is greater than 0. Okay, here we have 17,219 and 17,198. So we have 1 and 1, can't tell. 7 and 7, can't tell. 2 and 1. 2 is greater than 1. Okay, we have 34,387 and 34,387. We have 3 and 3, can't tell. 4 and 4, can't tell. 3 and 3, can't tell. 8 and 8, can't tell. 7 and 7, can't tell. So these two numbers are equal. Okay, 83,499 and 83,500. Let's see, we have 8 and 8, can't tell. 3 and 3, can't tell. 4 and 5, 5 is greater than 4. All right, last one, 96,879 and 97,779. Let's see, we have 9 and 9, can't tell. 6 and 7, 7 is greater than 6 and 6 is less than 7. B, complete the list of multiples. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Then we have 4, 8, 12, 16, 20. Let's see, 4 times 6 is 24. This is 4 times 1, 2, 3, 4, 5, 6. 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. And 4 times 10 is 40. So if you'll look, this looks just like our T-charts, where if we would have had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going down this way, this would be what we put on the right. All right, so we have 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 56. And 6 times 10 is 60. I'm sorry, this is 54. Why did I do, I was thinking about 60. 54. Y'all probably caught it. All right, today is Monday, so do not watch any more of this video. Come back on Tuesday. Have a great day. Happy Tuesday, y'all. You should have done C and 1 today. So it says find the length of side Z. So here is side Z. It tells us that our perimeter is 5 units. So that means, remember, perimeter, add above sides. So that means that this plus this plus this plus this plus this is going to equal 15. But we're missing this part. Okay, so we need to figure out the missing part. So we have 2 plus 3 that equals 5, plus 3, that equals 8, plus 2, that equals 10. So we know that so far all of this equals 10. And we know that all of this plus this is going to equal 15. So that equation would look like this. 10 plus z equals 15. Okay, we need to use our fact families. So that means z plus 10 equals 15. And then it means 15 minus z equals 10. And 15 minus 10 equals z. So we need to do 15 minus 10. 5 minus 0 is 5. 1 minus 1 is 0. So z equals 5 units. All right, number 1. Bryce and Stuart each drew a square. How many centimeters longer is the perimeter of Bryce's square than Stuart's square? Now, a lot of you will look at this and you'll say, all right, if this is 15, that means that this is 15. But I'm missing these two sides. You'll say, if this is 10, then this is 10. Okay, you've got that down. Okay, but remember, these are squares. And with squares, every single side is the same length. So if this side is 15, that means that all the sides are 15. So we have 15 centimeters all the way around. And if this side is 10, that means that all the sides are going to be 10. So this one is 10 centimeters all the way around. So it wants to know how many centimeters longer. Look at the word longer. Longer is an ER word. And ER words mean that we are going to subtract. It says how many centimeters longer is the perimeter, okay, perimeter means add, of Bryce's square than Stuart's square. So first we need to find the perimeters of both of their squares. This is going to be 15 plus 15 plus 15 plus 15. Or it's 1, 2, 3, 4 times 15. Now that's easier for me to just go ahead and do 15 times 4 instead of adding 15 4 times. So we're going to do 4 times 5 is 20. And 4 times 1 is 4 plus 2 is 6. So the perimeter of Bryce's square is 60 centimeters. Okay, now we need to find the perimeter of Stuart's square. So that means that we would add 10 plus 10 plus 10 plus 10. But this is also 1, 2, 3, 4 times 10. And we know that 4 times 10 is 40 centimeters. Okay, we added, we found our perimeter. Now we need to subtract and figure out how many centimeters longer Bryce's square is than Stuart's square. So we're going to do 60 minus 40. 0 minus 0 is 0. 6 minus 4 is 2. 20 centimeters. All right, guys, that is all for Tuesday. Come back on Wednesday. Have a great day. Happy Wednesday, y'all. We are halfway through the week. You have done an awesome job this week. You are the bomb, and I miss you. All right, you should have done 2 and 3 today on Wednesday. So we have Justine receives 4 dimes for every 5 chores she completes. If Justine completes 30 chores, how many dimes should she receive? So we have 4 dimes for every 5 chores she completes. If she completes 30 chores, how many dimes should she receive? Okay, so this is going to be an input-output table. So we have number of chores and number of dimes. So we have 5 chores means 4 dimes. 10 chores means 8 dimes. 15 means 12, and 20 means 16. So they're wanting us to put a 30 in this spot. They're wanting to know if we put a 30 right here, how many dimes will she receive? So if you'll look here, this is counting by 5s. 5, 10, 15, 20. So let's put a 25 in here not to throw us off. Okay, and here we're counting by 4s. 4 plus 4 is 8. Plus 4 is 12, plus 4 is 16. So if we do 16 plus 4, That means that if she has 25 chores, she'll get 20 dimes. Then if we add 4 more, she does 30 chores, she'll have 24 dimes. So if she completes 30 chores, she will receive 24 dimes. Because we added 4 each time. Let me make this bigger. 5, 10, 15, 20. Then we have 25, 30. Here we had 20 and 16. So if we add 4 to 16, we get 20 here. Then if we add 4 again, we get 24 here. So for 30 chores, she'll get 24 dimes. All right, number 3, it says circle the comparison that is correct. So here we have 1/6 is greater than 1/2. Now remember, we talked about how if the numerators are the same, then the alligator is going to eat the smaller denominator. So that means that 1/2 is going to be greater than 1/6. Let's look at that. Let me get my fraction strips out here. Here's 1/2 and here's 1/6. So 1/2 is going to be greater than 1/6. So this is not true. Now this one says 2/2 is less than 2/4. So look, our numerators are the same. So our alligator is going to want to eat the smaller denominator. Let me get 2/2 and 2/4 out. Can't even see that because it's so big. All right, let's see if I can, no, I can't zoom out. Okay, so here's 2/2 and here's 2/4. Okay, 2/2 is equal to 1 whole. Look, the numerator and denominator are the same. Okay, so that's saying, that would be saying that 2/4 is bigger than 1 whole. That is not right. Okay, that is not right. Okay, the next one, 1/2 is greater than 1/3. Our numerator is the same. The alligator is going to eat the smaller denominator. That is true. So here's 1/2 and 1/3. And 1/2 is greater than 1/3. Okay, this one says 2/3 is less than 2/8. So remember, numerator is the same. Alligator is going to eat the smaller denominator. It should look like this. So let's see, 2/3. Here's 1. 2/3 and 2/8. Okay, here's 2/3 and 2/8. Okay, 2/3 is a lot bigger than 2/8. So this one is not right. All right, guys, you are done for today, Wednesday. Please come back tomorrow on Thursday, and it will actually be our last day together because Friday is a school holiday, so you don't have any work to do on Friday. So come back tomorrow for the last little bit of your daily rigor. Have a great day, guys. Happy Thursday, y'all. This week, today is actually our Friday. Whoop, whoop. All right, so for our last little bit of our daily rigor, we should have done 4 and 5. So basically, we should have finished it. All right, number 4. Gustavo is making a number pattern. What 3 numbers come next? So the first thing we need to do here is determine our pattern. So our numbers are getting bigger. If they're getting bigger, that means that we are either adding or multiplying. So we always need to try adding first. So to get from 115 to 118, we are going to add 3. So let's see if that's our rule. 118, 119, 120, 121. Yep, that works there. Now let's see if it's the rule here. 121, 122, 123, 124. Yep, that's our rule. So now we know that we are just adding 3 every time. So we can go ahead and plug that in. Okay, we're going to do 124, 125, 126, 127, 128, 129, 130, 131, 132, 133. So our three numbers are 127, 130, and 133. All right, number 5. I cannot zoom out any, so I'm going to just slide my can. Okay, the dot plot shows the number of phones in 24 homes in Tina's neighborhood. Each dot represents one home. So remember, the first thing we do when we see a graph is to number it. So number of phones in each dot is is one home. So 0 phones, 0 homes have 0 phones. 1, 2, 3, 4, 5 homes have 1 phone. 1, 2, 3, 4, 5, 6, 7 homes have 2 phones. 1, 2, 3, 4, 5, 6 homes have 3 phones. 1, 2, 3, 4, 5 homes have 4 phones. 1 home has 5 homes, and 0 homes have 6 or 7 phones. Homes and phones rhymes too much. All right, A. How many homes have 6 or 7 phones? How many homes have 6 or 7? Now, that doesn't mean just 6. That doesn't mean just 7. It doesn't mean 1, 2, 3, 4, 5, 0. It means 6 or 7. So it wants us to count up how many homes have 6 or 7. So if there were numbers here, then we would add them. And it would be 0 plus 0, which equals 0. So 0 homes have 6 or 7 phones. Okay, B. How many homes have 3 or more phones? 3 or more. Okay, that doesn't count 0. It doesn't care about 1. 1 is less than 3. It doesn't care about 2. 2 is less than 3. It cares about 3 or more. So 3 and every single number past 3. 3 or more. So we're going to do 6, 7, 8, 9, 10, 11, 12. And then these are both 0. So our answer is going to be 12 homes. All right, last one, C. How many homes have 1, 2, or 3 phones? Look, 1, 2, or 3. It doesn't care about 0. It doesn't care about 4, 5, 6, or 7. It cares about 1, 2, or 3. Okay, so we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 homes. 18 homes. All right, guys, that is all of our daily rigor for this week. I am so excited that we finished another week of online learning, and I can't wait to see you next week. Make sure that you get all of your work turned in for every single day. Love you guys. Bye.